Right, we're back to this again, I'm afraid, because it's really important that we do these diagrams carefully, and the only way I can think of doing it is to do it like this. So we're going to look at reflection today. Again, there's a video to watch as well, but again, it's these diagrams, you have to draw them correctly at GCSE, so we're starting now. So the title's Reflection. Today's date is I'm now doing this on a Tuesday, so it's I think it's the 21st of May, 21/05/2020. Oops, I've just messed up that, never mind. Try and do that neater than I have, if you can. Hands mending, look at that. Right, so we're going to look at sending a light wave into a mirror, okay? And we draw these in a certain way. So I'm going to come down a couple of lines. And I'm going to draw a mirror. So the symbol for a mirror, and this is called a plane mirror, P-L-A-N-E. It's a geometric word. Yeah, it means it's completely flat. And I show that the shiny side of the mirror by putting these little lines on. So this is the non-shiny side of a mirror. Okay, so put little kind of like diagonal lines on. So this here, if we label it, again we label in put a line there. So this is a plane mirror. And we're going to send a light ray onto this mirror. Okay. Now I should really have a protractor here, and I don't. Therefore, I've got a little bit of gold paper here, because angles are super important. Okay. So I'm going to kind of put that here so I get a perfect little angle that I can use afterwards as well. So I'm going to use this. Again, you could use a set square or something, or you've probably got a protractor anyway. Okay, so that's my light beam coming up. And this point here, where it hits the mirror, is really important. Because here I'm going to put a vertical line, a perpendicular, so 90 degrees to the mirror surface. And we show that as a dashed line. And we call this a normal. So this is the normal. Okay. And this is a light ray coming in and hitting this point here. So this is coming in. So I'll put a little arrow on that. Avoid putting an arrow here because I'm going to do other things here. So this is it's called the incident ray. Okay. And this is coming in at a certain angle. It's going to reflect off this mirror. It's the same as if I had a ball in my hand. If I was here and I wanted to hit someone with a ball here, I'd use my innate knowledge of physics to know that I'd have to hit the wall at a certain angle so it bounces off and hits the person. Okay, it's like squash is all about these kind of things. Okay, so yeah, this incident ray is hitting or striking the plane mirror at an angle, and that angle is here. Okay, we always measure to the normal, not here, to the mirror, to the normal. And this is called I. It's the angle of incidence, and we're going to get to that in a minute. Now, if we do this, and it's a plane mirror, the ray that reflects off it, called the reflected ray, would be the same angle. So the angle I equals the angle R. So I need to turn my gold piece of paper over to get that same angle. There it is. So I'll line that up now on the normal, and I can draw my reflected ray. That's the same angle. So there's my arrow. So this is R. Lowercase I, lowercase r. So this is the reflected ray. If we're in class, we'd be shining beams of light on plane mirrors and kind of measuring this. It's quite, not the most exciting thing because it's kind of obvious. From living our lives, we know that this is the case. Yeah, that I equals R. Okay, so underneath I can put that. So the angle of incident. I can't write today, can I? Incidence equals the angle of reflection. And therefore that's I equals R. That's the equation that we need to know. So the incident ray and the angle of incidence is just a different tense on the word. So yeah, we need to know that I equals R when we're dealing with reflection. So that's the end of the diagram.